Let's continue with another group of arc welding processes. This time we are going to consume the electrodes. In the previous ones, we weren't consuming the electrodes. It was the same throughout the process, but now we will talk about some types of processes, arc welding processes, in which these electrodes are consumed and we need to be feeding them all the time while we are performing the welding operation. The first one is called as shielded metal arc welding, and it's the most popular, most simple one, and also it's quite versatile. And that's why it's for most of the time, about 50% of the time, in industry, people use this welding process compared to the other welding processes. And this one again, we generate arcs by using electrics, and the actually arcs are generated between the tip of the electrode we are using, and this electrode is actually a coated one, and the workpiece. So arcs is always in between the electrodes and the workpiece. But the thing is that once you touch the workpiece, arcs are started, but you will remove it a little bit so that there is a little gap between the electrode and the workpiece, and with the help of it, you will have a continuous actually arcs generated. And while we are performing this operation, with the help of actually the heat generated, the metals which are being actually joined are melted. We have coatings all around. So they are since broken, they are again melted, and also the electrode itself is melted. So in the mixture, in this molten mixture, we have some materials from the base metal, some materials from the electrode metal, and some materials from the coating. So this is a quite complicated mixture. With the help of it, we try to join these parts and increase their strength, increase the strength of this fusion. And you can see a simple schematic of shielded metal arc welding. You'll see this is our kind of power supply. One side is connected to the workpiece and the other side is connected to the electrode. So that's why once you touch these together, we have arcs generated. And if you look at the close-up view of this welding zone, you'll see we have a kind of a shielding gas. Although we don't have an external supply of shield gases, inert gases, with the help of the coating, you'll see we have a kind of an inert atmosphere around the welding zone, and that's why the quality of the weld is quite acceptable. And once this actually flux is actually solidified, you have a kind of a layer on top of this weld region, and that is called, as we discussed, slag, and that should be removed after this welding operation is over. And if the thickness of your parts to be joined together is quite higher, then what do you do? Instead of passing a single pass, you may do, as you see, as much as 8 or 10 passes, so that these thicker workpieces are joined together. Then we have the second type. This is called as submerged arc welding. And in this process, we make use of granular flux. And I will show you the schematic of this process. You see these are the workpieces which are to be joined together in a moment. And actually the top part of this weld is covered with this granular flux which are supplied from this hopper. And this is our continuous supply of wires. And again, similar shielded metal arc welding, the arcs are generated and the parts are joined together, but instead of coated using coated electrodes, we are using pure wires, bare wires, but they are protected. This welding zone is protected with the help of the flux poured over our welding zone. And later, this flux, most of the flux is actually recovered, and then later you can use them in your other welding operations. So actually the flux is acting as a thermal insulator. With the help of it, we don't have any actually arcs spattered around. The UV lights are suppressed and all the fumes are suppressed. And another thing about the shielded metal arc welding is that due to the actually use of flux, is quite faster compared to the shielded metal arc welding, and this ratio is sometimes up to 10. So if the speed is important for you, then you may go with shielded metal arc welding compared to actually go with submerged arc welding compared to shielded metal arc welding. Then we have another consumable type of arc welding process called as gas metal arc welding. In the earlier days, it was also called as metal inert gas welding. And the thing is that it's somehow similar to gas tungsten arc welding. The difference is that we are using a consumable electrode, and the other things are somehow similar. Let me show you an equipment for the welding operation. Gas metal arc welding, you see we have power supply, we have gas supply, inert gas supply, and again we have a kind of a welding torch. And at the tip of this welding torch, obviously, we have this gas, shielding gas supplied. We have this continuous wire, which is responsible for filling the gaps and generating the arc between the tip and the workpiece. And obviously, since we are not using any coating, any flux, the area is actually protected with the help of this inert gas. And in addition to sometimes inert gas, you may embed some amount of deoxidizers into the wires so that the amount of oxidation is decreased or is totally eliminated. And the temperatures are not high compared to previous arc welding processes. So that's why we can mostly work with thin sheets of metals. For thicker ones, this is not preferred. And on the other hand, we don't have any material restriction. We can work with ferrous metals, non-ferrous metals. And this process is quite versatile, it's economical, and maybe the most important thing, it can easily be automated. So if you have a kind of a robotic manipulator, and if you want to do a robotic welding, then that is the best process actually suitable for such robotic applications. Then we have another arc welding process. It's called as flux cored arc welding. And the main differences, as you see, is in terms of electrode, the type of electrodes. The electrodes is actually the interior of the electrodes filled with flux. It is a kind of a flux core at the center. That's why it's named as flux cored arc welding. And the other things are similar to gas metal arc welding. With the help of this core being at the interior of the electrode, actually results in much more stable arcs, and the quality of the joint is much better, and we have better mechanical properties. And the electrode itself is actually a bit more flexible than the electrodes we were using in shielded metal arc welding. The ones in the shielded metal arc welding is quite rigid. Once you actually bend a little bit, they will be broken, but the ones we are using in this process is quite flexible, and we can easily feed them through some tubes. And this is an example of flux core arc welding. This is, as you see, the electrode itself is quite thicker, and at the center of it, at the core of it, we have this flux, and inside this flux, we have some gas-forming materials, the oxidizers, some metals, so that the resulting actually weld will have better properties. And due to actually having such extra chemicals inside this core, we don't need to apply extra inert gases into the welding zone. Without it, we can perform this process and still have actually better properties. And in summary, we can say that this welding process is a combination of shielded metal arc welding, since we have a continuous supply of actually it's quite versatile like shielded metal arc welding, and it's similar to gas metal arc welding, since we are supplying our wire continuous, as in the case of ME202. And again, it's quite economical, provided that the cost of actually electrodes are not expensive, but the rest of the process is very similar to other ones, so you don't need to have some other special equipment. Then we have electrogas welding. This is a bit different than the previous ones, and we use this actually for welding the edges of some thicker workpieces, and you place them against each other, and this is called a butt joint. And then with a single pass, we join these edges together. You can have a look at the schematic here. It's much more complicated, so it's also called as a kind of a machine welding operation. So this, assume that this is our kind of machine. We are again supplying our welding wire into this kind of nozzle. As the temperatures are quite higher, we have some water cooling systems. Then this is the welding zone. With the help of it, by moving our equipment upwards, this these edges are joined together. Then we have another similar version called as electroselect welding. And this time the difference is that the arc actually started with the tip of the electrode and the bottom of the workpiece. This is the schematic of it again. It's quite complicated with respect to other arc welding processes. So we start from the bottom of the welding, and then with the help of this equipment, we go up and try to join these two parts together. And these are mostly utilized for quite larger and thicker workpieces. And now let's briefly talk about the type of electrodes we are using in these arc welding processes. So how we are classifying them, we usually consider their strength, and we consider the type of current we are going to use in the welding process and the type of coating actually required for this process. And then according to these properties, we select the right type of electrode for our application and do the welding process. And you have seen that in some of them, we have coatings around the wire. So they are mostly clay-like materials, and inside these materials, we usually have some binders, other powdered materials like oxides, carbonates, fluorides, and some other alloys, and wood floor even. And for most of the time, it's quite brittle, but as we have seen in the submerged arc welding, it's not brittle, and not submerged arc welding, but it's actually gas metal arc welding, the flux core arc welding. These are quite difficult to remember all the names. The one we are using, in which the flux is at the center of this electrode should be a bit flexible, but the other ones are quite rigid, but the thing is that they are brittle, so you should be careful about this issue. And what are the functions of the coatings we are using in these processes? First of all, they need to stabilize arc so that the quality of the weld is high, and we always have high temperature around the welding zone. And in some of them, they are responsible for actually generating gases so that around the welding zone we will have a protected atmosphere, and that will again decrease the amount of oxidation. And they should also be able to control the melting rate, and maybe most importantly, they should act as a flux so that the weld will be protected against any formation of oxides, nitrites, and other inclusions, dirt. So that's an important issue. And as you know, once this flux is solidified, we need to be removing it, and the slag should be again protecting the molten weld pool. And inside this coating, sometimes we have alloying elements, and with the help of it, once you do the welding operation, these alloying elements will be embedded into the weld zone, and that would increase the quality, the strength of the welds.